Hello chaps and chapettes. So we just finished looking at the nucleus itself and now we need to make things slightly more complicated. We're going to know what an isotope is, and you've probably heard this word used before in relation to nuclear reactors, and you may have even seen it on The Simpsons because, well, Springfield's baseball team is called the Isotopes, named after the giant nuclear power plant that basically runs the entire economy in that town. So, we need to know what an isotope actually is, so you know what people are talking about, and you need to understand that actually all atoms are isotopes. They're just an isotope of a particular element. And we need to calculate the number of neutrons in an isotope. And that's going to be a relatively straightforward one. If you can add and if you can take away, then you can work this out. So the challenge today is to think about what happens if you have too few or too many neutrons inside your element, inside your atom. So let's go on from there. So we're looking at now 3 oxygens, and we've got oxygen 16, oxygen 17, and oxygen 18 on there. Now you need to know something about isotopes. Isotopes are forms of elements that have the same number of protons, but they have different neutrons. Now the number of protons is really important to an element. It basically defines the element's soul, or the atom's soul. If you've got 1 proton, you've always got hydrogen. If you've got 2 protons, you've always got helium. And that's going to govern how it interacts with things chemically and basically makes chemistry work with things. Now you don't want to confuse an isotope with an ion. An isotope has different numbers of neutrons, and honestly it makes very little difference in terms of chemical interactions. An ion has different number of electrons, and that has drastic implications for how it operates in chemical molecules. So there we go. Looking at the 3 examples we've got down there, this is oxygen, and we know it's oxygen because it has 8 protons in there. And we know that it's going to have a different number of neutrons because the atomic mass at the top there is, well, different. So I'm going to show you now how to calculate the number of neutrons inside an isotope, and it's a relatively straightforward calculation, and I'll see you at my board. Okay, so here we have our 2 oxygen isotopes. Now, remembering from the last video we looked at what these 2 numbers mean. We've got a proton number down here and the mass number up here. So this means we've got 8 protons and 8 protons here. Basically, we've got an oxygen atom. Good, makes sense. But then we have the change in our atomic mass number. So we want to find out how many neutrons are in this one, or in these 2, because they're both isotopes of oxygen, they're both the same thing, but they have different numbers of neutrons. So what we can do is start doing a bit of maths. Okay, we find out this one, we've got 16 for our mass number, take away 8 for our proton number, and we're left with 8 neutrons. Easy. And then 17 over here for our atomic mass number, 8 protons, which leaves us with 9 neutrons. And there we go. It is as easy as that. Now, the number of neutrons does have some implications for, basically for radioactivity in isotopes, for radioactive isotopes. Typically, if you've got more neutrons than you do with your protons, or at least more than you actually need, you're probably going to get something called beta emission. Okay, so that's how that works. Typically, if you've got too few neutrons, then you actually get alpha radiation, but that really only works with much, much larger atoms. We're talking things like uranium and stuff like that. Not really going to happen with the smaller things, and definitely not with the ones or the elements you'd be encountering into GCSE. Things all the way up to things up to neon and argon. You're unlikely to get radioactive isotopes from those ones. Radioactive isotopes from those elements. So, there you go. Nice and straightforward. We've got some easy maths, and there you go. Okay, so now you should know what the definition of an isotope is, and you should understand that basically all atoms are actually isotopes. They're just different isotopes of the same element. Now you should be able to calculate the number of neutrons inside an isotope, and if you can't do that, go and grab a periodic table and start doing some maths, calculating the number of neutrons and protons inside every element there. Now it depends on the periodic table you get, but there isn't actually an extra challenge on this one. First challenge, what happens if you have too few or too many neutrons? Have a think about that, let me know in the comments section below. But the next challenge is to think about why some atomic masses have decimal points. Depends on the periodic table you've got. Most of the GCSE ones will be whole numbers, so that's nice and easy. But if you get like an official one, or a more scientific one, you can see that they've got like, well, I think for hydrogen it's like 1.006 on the atomic mass, which makes no sense. It's like having 0.006 of a neutron, and that doesn't work. So I want you to have a think about that, and then let me know in the comment section below why that's happening, okay? Alright, remember to like, comment, and subscribe so that these videos can get spread out to people that need them, and I'll see you in the next video.